Now we have a few quadratic inequalities. Yeah, let's go ahead. Number A, we just try to isolate x on one side. Expand this bracket. And we already see plus 2x plus 1 on both sides. So we just have x squared less than or equal 8. Now when we take the square root, it might just look as if x is less than or equal than the square root of 8. And we've learned how to reduce square roots. Square root of 8 is just the double copy of the square root of 2, because it contains a factor of 4. But make no mistake, this inequality holds for the absolute value of x. X can be negative, but it can't be too negative, because a number that is too much on the negative is actually in the square very large, larger than 8. So what actually happens is 2 square root of 2 is here, 0 is here, this is minus 2 square root of 2. We're looking for numbers that are 2 times square root of 2 or less, but in the negative, the opposite of 2 square root of 2 is the limit. Any number that is out here has as its square a positive number larger than 8. Number B. Now this is 7 plus 7x squared. And here we have a binomial formula. Two minus 7 is minus 5. And here we have 8x squared, 8x, and 2. The 8x gets subtracted anyway. And we can subtract 7x squared to just have x squared on the right-hand side. And we also subtract 2 to get minus 7 greater than or equal x squared. So x squared would have to be a negative number. We've learned that the square of a number is always positive or 0. It can't be negative, so no number can make this happen. And the third quadratic inequality, we have again a binomial formula. Minus 6x disappears. And all these quadratic inequalities, they are specially prepared, so either the linear term disappears, so you just get an inequality in x squared, or the quadratic term disappears and you have a linear inequality. When you have an inequality that contains both x squared and x, this is something for next year. So we get 9x squared greater than 81, and we can divide out the 9. Of course, we recognize a factor of 9 in the 81. X squared is larger than 9, so the absolute value of x is greater than 3. So, and the number line, we get all the numbers greater than 3, excluding 3, but also their opposites, their mirror images. We've learned how to write this. The set of solutions is the interval from minus infinity to minus 3, excluded, in union with the interval starting at 3, excluded, up to infinity. Oh yes, I never wrote the set of solutions for number A. So this is the full interval, minus 2 squared 2 up to positive 2 squared of 2, So this is painted in as well.